Hello everyone, I am Dr. Godandaraman. In this section, we are going to discuss with MCQ, multiple choice question, unit 1. Look at this one. A random variable x has the following probability function, the value of a is. So now look at this problem. X values are 0, 1, 2, 3, 4 and the probability value of a, 2a, 5a, 7a, 9a. So the values are countable and finite number of value, therefore the given problem is discrete. If discrete means the probability mass function is nothing but summation of p of x equal to 1, the x range minus infinity to plus infinity, total probability value 1. So when x value 0 to 4, because here given 0 and then 4, probability of x equal to 1. Now substitute x is 0, p of 0, p of 1, p of 2, p of 3, p of 4 equal to 1. So p of 0, this is the a, p of 1, 2a, 3a, 5a, 5a, 7a, 9a equal to 1. Now the total value 3, 8, 15, so 24a equal to 1, a equal to 1 by 24. So the option 1 by 24, option A. And what is the expected value of continuous random variable x with the probability density function f of x given? So now to find the expected value of continuous random variable. So expected value when is a continuous, e of x, expected value is nothing but expectation of x equal to, when is a continuous, integral minus infinity to plus infinity x f of x and dx. The range given 0 to 1 x into f of x 3x square into dx. Therefore 0 to 1 3x cube dx. When I am integrating 3 constant, x cube integration is x power 4 by 4, 0 to 1, upper limit and lower limit, so 3 by 4. So 3 by 4 in decimal, because to calculate 3 divided by 4, 0.75. So the 0.75 option is C. So this is a option is C. This is not B, option C. And then next, if k is a constant, now to check the property, when k is a constant, then the expectation of, what is a property? Property expectation of constant, variance of constant 0. So this is a condition. Here k is a constant, therefore the condition is nothing but expectation of constant equal to constant and then variance 0, option C, option C. And then the mean and variance of random variable x1 and 2, then calculate the mean and variance of random variable y equal to 3x minus 2. Now the problem is mentioned expectation of x1, variance of x2. Now the question is expectation of y. So expectation of 3x minus 2. So using the property 3 into expectation of x minus expectation of 2. So expectation of constant is constant. So 3 expectation of x minus 2. So expectation of x value 1. Therefore when I substituted 3 into 1 minus 2, 1. So expectation of y value 1. See here 1. And then variance of y. So variance of y, variance of 3x minus 2. The property is nothing but variance of ax plus b equal to a square into variance of x plus or minus. Therefore here 3 square variance of x. So 9 into variance of x, then 8. The option is nothing but mean of y 1 and the variance of y 18, the option B. Now the probability of impossible even. Impossible means possible even 1, impossible even 0. A constant, then expectation of Ax. So expectation of Ax property, A of x equal to A into expectation of x. The option is C. And C is the constant. The variance of constant is 0. Expectation of x square is 6. Expectation of x 2, then find the value of variance of x. So variance of x is nothing but expectation of x square minus expectation of x whole square. The values are given 6 minus 2 square, 6 minus 4, 2. The option A, 2. And next to problem, variance of. So what is the variance? See property, variance of Ax plus b, a square variance of x. Therefore for here variance of 2x plus 3, so 2 square variance of 3. Now 2 square 4 variance of 3. See the option 4 variance of 3, option C. And next problem, see the distribution function of random variable x is given by capital F of x 1 minus e power minus x, x greater than or equal to 0, find the density function. So when the capital F of x given, to find the small f of x, d by d. So how to find small f of x? D by dx of capital F of x. So now differentiation d by dx 1 minus e power minus x. When the differentiation 1, 0 minus e power minus x differentiation e power minus x into minus 1. So minus minus plus the value of f of x e power minus x. Now see where e power minus x, option D. Now if f of is distribution function of continuous random variable x, and if a less than b, then probability of a less than x less than or equal to b. This is a CDF property, f of b minus f of a. When the condition is given, if suppose a less than or equal to x less than or equal to b, or a less than x less than b, or a less than or equal to x less than b, or a less than x less than or equal to b, every value in continuous cases f of b minus f of a, the property satisfying the condition. Then distributions. Still now we have discussed random variable type of problems. Now binomial distribution. So mean of the binomial distribution n into e of x, mean of binomial n into p. A coin tossed 300 times, find the mean of binomial distribution. Here expectation of x n into p for given n 300, and probability is nothing but coin probability 1 by 2. Therefore expectation of x np equal to n 300 1 by 2. So 150 is the answer. The option is D. And the variance of binomial distribution, variance of x npq, option B. And then binomial distribution, mean of binomial distribution is given 20. So expectation of x np value given 20. Standard deviation is nothing but 4. So variance of x, standard deviation is nothing but square root of variance. Standard deviation square root of variance. So root of 4, standard deviation is 2. But standard deviation square, now what is the value? Standard deviation is 4. Now the variance is nothing but, because find the n parameter. N parameter is nothing but the value of here n value to calculate. Now the variance of x equal to npq. Therefore from this equation standard deviation is nothing but square root of standard deviation square root of variance of x. From this variance of x, standard deviation square. Therefore, here given variance of NPQ is nothing but 16. Therefore, now to calculate NP value, NPQ by NP. So NPQ by NP. So now this term to cancel, PQ, so NP by NP to cancel, and then 16. So Q equal to 16. NPQ by Q, 16 by 20. So 16 by 20, 4 by 5. From this one, what is a P value? P equal to 1 minus Q. So 1 minus 4 by 5, 1 by 5. Now what is the value of NP? NP equal to N value to calculate. So N into P value 1 by 5. So NPQ 20. N equal to 20 into 5, then 100. So now the option 1, A, 100. Then find the variance of Poisson distribution. Variance of X is nothing but lambda. Then the moment generating function of Poisson distribution, mx of t e power lambda e power t minus 1. Therefore, the option B. The mean of Poisson distribution, E of x lambda. Option A. The condition when the Poisson distribution is viewed as a limiting case of binomial distribution, then lambda is nothing but lambda equal to n into p. The option A. If n is 100, p is 0.2, then find the parameter of the Poisson distribution. Parameter is nothing but lambda, so n into p. N value given 100, p value 0.02. Therefore, the value is nothing but 100 into 0.02, the value 2. Lambda 2. Option B. If a random variable x follows a Poisson distribution with the lambda 2, then the probability x equal to 2, what is the value? Now the function x of x Poisson distribution e power minus lambda power x by x factorial. When the lambda value 2, therefore x equal to 2, then e power minus 2, 2 power 2 by 2 factorial. E power minus 2, 4 by 2 to cancel this 2, then 2 e power minus 2 to calculate e power minus 2 value. So now what is the e power minus 2 is nothing but using the calculator to find e power minus 2. So e power minus 2 is nothing but 0.2 into 0.1353. So when we are multiplying 0.1353 into 2, so 0.2706. So the option is C. And mean of geometric distribution, the option is C. The option is to include D, 1 by P. So the answer is 1 by P. And the variance of geometric distribution, Q by P square. Option A. And the mean of uniform distribution, so B plus A by 2. And the x is the exponential distribution with the parameter lambda. Then for any two positive integer s and t, the probability of x greater than s plus t given x greater than s is nothing but the first option, x greater than t. So this is a memoryless property for exponential distribution. The mean of exponential distribution, expectation of x is nothing but 1 by lambda. So option is C. Then variance of exponential distribution is 1 by lambda square, the option is D. If the mean of exponential distribution 1 by 10, then the variance of the distribution, so variance of x 1 by lambda square, when the mean value, mean is nothing but mean is given e of x 1 by lambda given 1 by 10. So what is the mean? That lambda 10. Therefore variance of x 1 by 10 square 1 by 100. The option is D, 1 by 100. Which of the one of the following distribution satisfying memoryless property? So memoryless property satisfying two distribution. One is geometric distribution and other one is exponential distribution. So in this option we have only exponential, so option C is correct. And then the standard normal distribution represent this range n 0, 1. The normal curve is nothing but, so this is a bell shaped curve, negative side and positive side, negative, positive, this is a 0.5, this is a 0.5, so bell shaped, symmetrical about the mean. So normal distribution is the limiting form of binomial distribution under suitable statistical condition. So binomial distribution. Thank you.